Okay, I'm back. Thanks for bearing with me. I obviously have no control over the power grid. Adjust that a little bit. That's one of those things that we talk about, by the way, when we get to the network security class, is the network availability and network security, and power is one of the biggest issues that we have with workstations and servers, keeping power to our equipment. I don't want to get too much into that, but I just wanted to mention it since it was an issue today. Okay, so let me pull up a couple of pages here. Network design. I'll share my screen in just a minute here. I want you to go for right now, go to draw.io. For those of you that have not done this before. The reason I like draw.io is because you don't have to download a program. It lives in the cloud and uses HTML5. And you can store your drawings in Chrome. Moving monitors around here. Draw.io allows you to make these drawings without having to download any code, and you can save your drawings and your projects into the Google Drive. So it's the ultimate thin client for network design. So there is an assignment for draw.io. I believe I made it due this weekend as well. So I know you got a lot to do this week, but it's a pretty easy. There's actually 2 versions of the draw.io. So it's pretty easy to do. So let's take a look at that assignment just real quick. Let me log into U of H real quick here. Okay, under assignments. Draw.io assignment part 1. Let's take a look at it. Now, I know it says it's due April 27th. I did not make it due yet. Okay, that's good. You should still look at it though, because it's pertinent to network design. I'll probably make this due on Monday of next week. And again, it's not very complicated. So first of all, you're going to want to get an account at draw.io. It should be very easy to do. Go to draw.io. If you already have an account from your systems analysis and design class, that's great. Save diagrams. Save diagrams to Google Drive, not your local drive, because I'd like you to save your diagram to Google Drive and then share it with me. Not the output, but the actual diagram, so that I can go into my draw.io and mess with it if I wanted to. So I'm going to authorize draw.io to use Google Drive. Which I've done before, but not from this computer. So it's just asking me to do it again. I'm going to create a new diagram. So I want everybody to try doing this. You can do it right now if you want with me, or you can do this later on. The instructions give you a little bit of instruction, but actually not much. It basically describes via text what the EI lab looks like. And I'm going to leave it up to you guys to attempt to draw that out with draw.io based on this text. So no two diagrams are going to look the same because I haven't given you specific enough information. When we do draw.io version 2, I give you more specific information. So you're going to do your best with just the text that's been given to you. I highly recommend you watch these 2 YouTube videos. They are, one of them is an intro to draw.io by the draw.io people, and then the other one is a tutorial that a third party made on using draw.io to draw a simple network diagram. So to get started, watch those 2 tutorials. You can create one as you go, or you might want to start this way, and I don't care which direction you start in. I'm going to use an existing template. It's always better to learn how to do something by seeing something that's already been done. So if you click here on network templates, there are several that you can choose from. Let's just take a look at a simple one. Like this very last one is a simple Wi-Fi network. Let's click on this. Create. You can pick a folder on your Google Drive. I don't think I have one called draw.io. I think I have one called outages. So I'll just drop it into my UH folder and my MIS 4477 folder. It's going to save it as an XML file. Ooh, that's pretty sexy. I've obviously messed around with that. Okay, that's not the one I wanted to show you. Oh, that's a pretty messy one. That one. I'll just put it in a root folder for now. Okay, so give your document a name right off the bat. Don't call it untitled diagram.draw.io. Call it something that's descriptive. I'm going to call it Jake's MIS 4477 Wi-Fi network. Something like that. Okay. Notice it's an XML file, by the way. All right, so the elements that are common in all drawing programs are the entities themselves and then the connecting points, how the entities are connected. So in this example, which is probably what most everybody's home internet looks like, we've got the internet, which there are several icons that you can choose from to define and describe the internet. So that's what this maker of this template chose, but there's a bunch of different drawings that you can choose from. Or what's really neat about draw.io is if you don't like any of those pictures and you find a better picture, internet icon cloud, something like that. You find a better picture on the internet and you like one of these, for example, you can drag and drop that or copy and paste it or save it on your iDrive and then load it right into draw.io. So I should be able to find that. Okay, there's a nice blue one. Let's just drag and drop that. So I can use that, drag and drop it, and I can say, I don't like that dumb picture. And I'll change my waypoint here. So I grabbed this line and I'm going to attach it to that drawing instead, to one of those waypoints. Then I'll throw that one away. Oops. Where's the delete button? There it is. Okay. So you'll notice on each entity, and again, you can go through the tutorial on this. Each entity, it gives you each item that you draw on there, each icon has a certain number of waypoints already attached with it, the internet on its side. And so when you're using these connecting lines, and use your best judgment. I recommend creating a legend that you put in the corner that indicates what each waypoint basically is, whether it's a cable modem cable or Ethernet connection, or in the case of these connecting points, these are attempting to show a wireless network. So the author chose to use lightning bolts for wireless. But if you use connecting points and connect them to a waypoint, you can move the entities around and the connecting points move with it. That's why I really like draw.io. Visio didn't used to do this. Visio does do that now. So each of these little items have waypoints. So make sure when you're drawing these things, you actually attach the lines to a waypoint. Don't just turn this in for your assignment. This is just an example of one. Try to create one on your own, but you can use this as an initial starting point, okay? Maybe rather than lightning bolts, you use some other connecting line. There's lots of line choices that you can choose from. Or you can find a picture and turn it into a line drawing. So play around with draw.io. It's fun. I think it's fun to play around and draw drawings. And it's very useful, like I said. The first thing, like for example, I had to go to one of my clients today because this brownout caused a lot of problems for them. And we were able to whip out the network maps because some of the network equipment came up, some of it didn't, some of it was dead. And I'm like, well, the power's back on, so it shouldn't be dead. There's way too many wires and way too many connecting points between the internet coming in the building and the workstations that were not working. So we were able to whip out the network diagrams that we created, years ago. Granted, they were not updated, which was kind of bad because things had changed. The customer had changed some things and not updated the documentation. Don't worry about the EI lab assignments right now, Mike. You don't need the EI lab to do the draw.io. The only thing that you need the EI lab for is to do the Wireshark assignments, which we're not working on yet. So play with draw.io. Anyway, so network diagramming, network documentation, diagramming. Visually, humans think better. It's easier to grab a map and follow the map, especially when you're trying to figure out from point A to point Z where a breakdown occurs. You might not know and might not remember because a lot of the equipment, a lot of the connecting devices, a lot of the connecting apps, if they're just applications, you don't see those because they're in the cloud, they're behind a wall, they're in a closet, they're in a main distribution facility location somewhere in your building, and you need to know possibly, excuse me, where those are. So I cannot stress, the reason I'm spending a lot of time on this is I cannot stress the importance of having network maps and network documentation to follow and to update it as well. Okay, so let's start into chapter 6. We'll obviously have to finish the rest of chapter 6 later. I may finish it tomorrow. I may try to do an additional PowerPoint offline later this evening if I have time and sew those two together. When the next exam will be, the next exam is going to be when we finish chapters 6 through 9. So it's looking like about Tuesday. Okay, that's what it looks like right now. It's going to come a lot faster than the first exam. We don't have a lot of time in this semester. We're supposed to be doing 5 days a week, which means I'll probably, because of interruptions and power outages, things like that, we're going to have a Friday class again. Okay, so how to design. Now we're going to talk about not using design tools yet. We're going to talk about designing a network, not necessarily from scratch, but what are the concepts in designing a network. So there's just a little layout of the next few chapters. Chapter 6 is network design. Chapter 7 is all about LANs. Chapter 8 is all about backbone networks. And Chapter 9 is about wide area networks. Backbone networks and wide area networks are very similar. We'll probably be able to get through chapters 7 and 8, or even 8 and 9 in one class sitting. Okay. I haven't, yeah, I'll publish an official due date for draw.io. Okay, let me do a shift F5. Network architectural components. Here's an example, another example of a network diagram. This happens to be, and you got to keep in mind when you're looking at network diagrams, you might have several different layers, mostly regarding scope. That is how fine-tuned you are, how close in you're looking at a particular network. This network diagram is a very large overall diagram. It does not show all of the fine points of all the connections. This is showing the relative connections between different buildings at a campus, where the core layer is, for example, and the enterprise part of the network, and then where the internet service providers connect us to the outside world. So this is a fairly far back view of a university's network. If we zoomed in, like on one building, for example, like Melcher Hall, for example, we would look at a different set of network diagrams which described each of the floors within that building and each of the departments within that building. And then we might zoom in even closer on another set of diagrams which shows the individual LAN connections between all the workstations in one network, and how the printers connect, and how that network connects to the outside world and connects to the MDF, or the main distribution facility on that floor or in that closet, or maybe the IDF. That's another term. And when you go back to Melcher, by the way, and I'm going to point these things out later, I'm going to want you to walk around. I'm going to send you on a little scavenger hunt if you're not already graduating. And I know you'll be out of class by then, but I'm going to send you on a little scavenger hunt because you need to keep learning this stuff. We have several interesting things to look at in Melcher Hall. You'll walk around and you'll notice on each floor there's one room on every floor that's labeled IDF. That stands for an intermediate distribution facility. We also have 2 or 3 actual server rooms, which you can view. There's one on the 2nd floor with a bunch of glass in front of it. You can look through the glass and see a bunch of servers. That's the AIM Funds Trading Center. Anybody ever seen that? It's down the, I believe that's the north hallway on floor 2. Bunch of neat computers to look at. So anyway, this could very well have been drawn with draw.io or Visio. Now, in designing networks, there's a traditional method of design, which is kind of like the systems analysis and design method, which we don't typically use for designing networks. A systems analysis and design network flow, it's changed over the years, but it basically starts with an identification of needs, or you identify what your needs are, then you identify your choices, and then you do testing and implementation, or implementation, then testing, then perhaps redesign. We don't use a system design lifecycle model. We use what's called a building block approach when we're designing networks, which is actually a circular approach. And I'll show you the circular approach and why we can't use a top to bottom approach when we're designing a LAN or a WAN or a backbone network or a new methodology to do something with respect to networking. So this is kind of what a systems analysis and design approach looks like. The approach to that is useful for static and slowly evolving projects and networks, but it's very costly to do this because of Well, I'll show you why in just a minute. It's very time consuming and the approach is just not adequate, mostly because things change so much in this industry. By the time you have identified all your needs, identified all the possible choices, gotten budget approval for certain choices, by the time you go out and buy this stuff, maybe the stuff you were going to buy, if it's a bunch of hardware, for example, has become obsolete, or there's better choices available that weren't available 3 months ago. Like maybe you were speccing out a bunch of workstations with 20-inch monitors. Well, now 20-inch monitors are kind of passe, and everybody's now getting 22 and 24-inch monitors, maybe for the same price. Usually, the bigger the entity and the bigger the budget, the longer this process takes place, and the more likely something like that is to have happen. I look at bid requests all the time, which spec out the requirement for workstations, for example, and some of the peripherals they request on the workstations are kind of old. Like, well, we don't sell 18-inch monitors, or we don't sell 4x3 monitors, or the workstations that we sell, the hard drives that we do put hard drives in them, the minimum size is 1 terabyte, and they may be asking for a 300 meg hard drive, or they may be asking for a real hard drive when our suggestion is put a solid state drive in there, almost the same price. So we use something called the building block approach, which is a circular approach. We first start out with a needs analysis. We try to figure out what the needs of the network are. What are we trying to accomplish? From there, we go to a technology design where we look at existing technology that's out there and figure out what will meet our needs. Then we go to a cost assessment phase. And this is probably the most difficult phase to get through, to get past. And this is what ends up making this circular. Everything that MIS does, unless your organization is in business specifically to provide MIS services or networking services to the rest of the world, or a particular industry like an Amazon.com or Amazon Web Services, or you're a platform. In other words, you're a cost center. An MIS manager doesn't make a company money. They are a necessary evil. They cost money. You're not selling widgets. You're not designing anything that makes the company money. What you're doing is you might be designing something, or you may be managing something which reduces costs. So MIS managers, interestingly, it's very difficult to measure their productivity. And the only way that company controllers and boards of directors really manage and monitor MIS managers' productivity is, are you staying at or under a budget? A lot of times those budgets are arbitrarily given to you based on previous performance, or based on what's called FTE, functional full-time equivalence, or amount of revenue, or amount of income, or number of employees. So this you got to get past, and sometimes you have to go back to your needs analysis and realize, oh, well, okay, we can't afford to get workstations for everybody with 32-inch, curved touchscreen monitors. Maybe we need to redesign or go back out and get pricing on workstations with lower end peripherals, then go back to our cost assessment and see if we're under that budget number or not. So let's take a look at the time here. I think all we're going to get through right now is needs analysis, but that's okay. Let's make sure that everybody fully understands what's going on in the needs analysis. We look at, first of all, why we need a network. Now, as I said before, 99.9% of the time when you're brought in on a job, let's say you're hired as an MIS manager or working for an MIS manager, you are probably already using a network. There's probably a network in place. You're not typically designing a brand new network for a brand new entity, which if you are, that's kind of fun. I love doing that. You're usually dealing with performance issues on your existing network. Geez, man, it takes forever to press enter and get some updates, or it takes forever to download something, or there's too many people on our network, so we're getting kicked off the network. The organization may be standardizing. This is happening a lot especially these days when two or more entities merge. For example, everybody knows about this new, you got lost over where, Franklin? What are y'all talking about? I got lost over there once, or Laura. I just saw that. Oh, you got lost in Melcher Hall? Melcher Hall is not easy to get lost in. It's a big triangle. Just keep going in. It's a big circle in the triangle. You won't get lost. Keep walking. The organization may be standardizing. T-Mobile and Sprint are merging. Okay. Forget about all the hardware of their network, which gives us as end user service. Think about all of the internal employees, the salespeople, the customer service people, the accounting people, all of the employees that are using a particular application, a particular desktop. They're probably using something different. It costs money for companies to not be standardized, because if somebody, let's say an employee is having a problem with their accounting software or their sales marketing software, they're going to call customer support, and customer support has to do a couple of things. They have to figure out, well, which system are you on? Which one are you using? Those customer support people have to be trained in both or multiple systems, basically. Give me one sec, please. And so standardization. When we talk about cost control, one of the most effective things you can do is standardization. It might cost a little bit of money up front to get rid of one of those systems or adopt a new system. And a lot of employees have a big problem with it. When two big companies like Sprint and T-Mobile are merging, you're going to piss off probably at least 50% of the employees, because they were used to using Salesforce, for example, and now they have to go use this other package that T-Mobile decided was better, or Sprint decided was better, or some new guy decided was better. Also, hardware may need to be replaced periodically. And keep this in mind, hardware is always going to fail. It's not a matter of if, it's a matter of when. You do not want to be replacing hardware after it fails or when it fails. You want to replace it before it fails, aka preventive maintenance. Change your brakes, change your tires on your car before you get a flat tire, before you have no more tread, before you have a car accident because your brakes are messed up. Preventive maintenance. It's the same thing with computers. One sec. So a needs analysis might be, well, with all of our stuff, although it's working, or a lot of our stuff, although it's working, is really old, we better replace it before it dies. Another good reason why a needs analysis might have to be conducted is certain operating systems, certain hardware may be going end of life, or EOL. Make sure you know that term if you don't already, EOL. EOL is kind of a bad word, or it's a scary word in my world. End of life or sunsetting. We hate that term. Oh my God, Windows 7 is being end of life. We're going to have to update everything to Windows 10. Sometimes that goes smoothly, sometimes not. Another part of needs analysis is what users and applications must be supported. Sometimes we are ending up having to support a brand new set of users, aka customers. Maybe we never supported the ability for our customers to log into a website to check their balances, for example, but now we need to do that. Why do we need to do it? Well, because we're trying to cut costs, because we're tired of customers calling all the time and saying, how much do I owe you? Or we're trying to keep up with the Joneses. We're trying to keep up with our competition who have a system where their customers can log in and make orders and check balances and pay bills. And gee, we can't do that. So we might lose customers to this other organization. The goals are going to differ depending on the network component and the scope. And that's why over chapter 7, 8, and 9, we learn individually the components and the function and the important items with respect to LANs, backbone networks, and WANs. As a matter of fact, most network technicians, most network managers, the area that they're working in, for a large size company, they're typically working in one of three areas. They're either working at a LAN layer closest to the end user, maybe they're working in a help desk, or they're working at the backbone layer, or they're working at the upper layer, the internet connectivity layer, or the integration layer, we call it, where they don't have a lot of contact with end users. Baselines. So as I said before, usually there's a network in place. So in terms of documentation, one of the first things I do when I go into a new network situation, a new job, is I conduct, especially if there's no network documentation, which is oftentimes the case with small organizations or with organizations that have merged, or one organization has bought another. This happens a lot. Companies merge with another company. All the other network managers and have been fired or let go, and the documentation went with them because it's either all in here or it's been erased on purpose. That happens a lot. You have to conduct a new baseline. This happens whenever in Congress there's a big changeover from the Democrats to the Republicans, and they're all using the same network hardware basically. So when the Republicans leave office, they wipe all the hard drives and kill everything, and the Democrats have to come in and reconduct a baseline, figure out, okay, how do we connect to the internet? Where's this, where's that, where's everything? It works either way, regardless of who goes into power. So baselines. When we're conducting a baseline, we need to look at things like a sequence of operations, the day-to-day or the week-to-week or even the monthly operations of how we conduct our business on the network, how we do backups, for example, how we make available the network to our end users. Processing times, how long is it taking to process certain transactions? Is it taking seconds, minutes, days, weeks? What are we trying to do? Are we trying to reduce those processing times? And in many cases, that's what you're trying to do, taking too long to process things. I remember stuff that I used to do back in the old days of networking would take, after we entered a certain amount of transactions, we'd have to go back and push a button and basically go to lunch or wait several hours before all these transactions were basically adjudicated into the networking system. Work volumes. What kind of work volume do we need to support? And if we're increasing our company size or decreasing, we need to redesign our network. Existing costs. Maybe we're trying to reduce cost. As I said, your cost. And next to employees, by the way, and I didn't mention this before, employees usually cost a company the most amount of money. Their payroll is the highest thing, unless they're building cruise ships or they're manufacturing something. The highest cost is your employees. The second highest cost in most company balance sheets is the networking function, the MIS function. So you're costing your company a lot of money. So they're going to be looking at your department and your function and the networking function and trying to figure out where we can cut those costs, which is okay because of the nature of what we do. A lot of the stuff can be automated at this level. And also we look at existing user and management needs. Sometimes we need to, like I said, allow certain users or give access to certain users that didn't have access to a network before. We need to give them access, like students or customers. And what kind of management do we need of that network? How fine-tuning of the management? Do we do all the management, or are we going to train somebody in that department to manage their own network? How are we doing on time? We're almost out of time for today. So there's a few steps here in the needs analysis. And this is one way to do it. We can break down the network into our architectural components. LANs, backbones, WANs. We try to deal with one chunk at a time. There's a famous saying, how do you eat an elephant? And you can think of a big network of a big company, that's an elephant. It's a huge elephant. How do you eat an elephant? Does anybody know the answer? One bite at a time. So you concentrate on one little piece at a time, or you allocate pieces and you tell one of your employees, okay, you take the tail, I'll take the trunk, you take the tusks, you take the eyeballs, whatever, you take the different pieces, and let's all work on our little piece of this. So we break down networking into different components. We evaluate all 7 components. We'll talk about the 7 components in a minute. It's often easiest to start with the WAN, the wide area network connection is the easiest typically because for a lot of companies, it's one connection. It's your internet connection. If you don't have a bunch of remote sites that you're connecting together, and this is usually a function of who you're paying for internet service. And you rely on them a lot for your technical specifications, recommendations, and the costs. So it's easiest to start with them. It's also a big part of your cost for a lot of entities. Some entities like U of H, our internet bill is probably to the tune of several $1,000s per month. Probably 20, 30,000 per month just to connect us to the internet. The geographic scope of the network, I mentioned that before. What is our network covering? Is it just one floor of one building, one campus? Is it an entire enterprise? Now, when I say that term enterprise, I hope everybody knows what that term means. That is all of the departments and all of the locations of a particular entity or company. Sometimes we use the term campus. Like in the case of the University of Houston, we have a campus, but many companies also talk about their locations as campuses. Like HPE, for example, has a campus in the not quite the Woodlands area. What do they call that area? The almost a Tomball. Exxon, Shell, they all have campuses where they have multiple buildings in a particular location, but that doesn't cover their entire enterprise. Exxon and Shell and Conoco, their entire enterprises, of course, are global. But you might be tasked with just looking at the needs of a particular campus, a physical location. Step 2, review the existing and expected applications that will use the network. And sometimes we need to upgrade networks because we've chosen different applications, upgraded applications. For example, we have been required to upgrade to Windows 10 because Windows 7 is going away, no longer supported. Well, that might mean we need to redesign our network or redesign our network nodes. Maybe there's a lot of nodes that can't support Windows 10. Maybe there's a lot of applications we're still using that don't run on Windows 10. So a lot of this is driven by the need to upgrade one particular level or layer of your network, which forces everything above and below it to be affected. Going from Windows 7 to Windows 10 is a great example. And that's why there are still a lot of big entities in this country and in this world that are still at Windows 7. Some are even at Windows XP. The FBI, for example, the Social Security Administration, Medicare. There are several entities where not only are they still at Windows 7 or even Windows XP, they're still using mainframe computers because they don't have the budgets. They don't have the programmers that can redesign all of their programs to run on newer operating systems. I'm gonna have to stop pretty soon here. Let's look at one more slide here. Review the expected applications that will use the network. Number 3 and 4, identify and assess network users. What we try to do is categorize our users into 3 or 4 different categories, depending on their level of need. Clerical users, for example, or we can go even lower than that. We can say that our customers is one level of user. They need a certain minimum level of security just to get into only certain things, just their accounts. Then you've got clerical users or salespeople or help desk people that need to be able to get into all of our customer accounts, but we don't want them to get into our financial information or our inventory. Then we've got engineers, people that are building things. They need to have very specialized workstations and very specialized software and applications which have nothing to do with selling anything. So you've got different categories of users, and many times you might have one employee, if this is a large entity, assigned to just that category of users. And you might be doing things like interviewing or holding meetings with those users and asking them, because a lot of times the only way we get this information is from our expert end users. And we say, okay, what are your issues? Where are your bottlenecks? We try to categorize our network requirements, and this is very, very important in our needs analysis for later on when we have to start scratching through the list of things that we can't afford, basically. So when we're redesigning a network, we try to categorize what needs are absolutely mandatory. So if, for example, it's been mandated that we've got to go to Windows 10, well, that's a mandatory requirement. We've got to be able to support Windows 10. A desirable requirement might be, it would be nice if all of our employees had bigger monitors. And I'm talking about a workstation situation. There's a much greater scope in a lot of areas, but this is easiest for you guys to understand. Desirable might be nice to have bigger monitors or 2 monitors. And then wish list items. It's important to have a wish list category and have certain things in there, because a lot of times network managers are not aware of or don't know some of the newer technologies or some of the reductions in costs of certain areas until they start going out there and looking. So categorize these so that when you get to that cost assessment phase, if you're above the budget, you can first scratch out all your wish list items and go, okay, well, I guess we can't afford everybody to have those $1,200 gigantic curved monitors. Have you guys seen those things, those crazy monitors? Depending on how tight the budget strings are of your organization, you may end up with only mandatory updates, or maybe not even some of the mandatory updates, as in the case of the Social Security Administration or Medicare or state and local governments. If you don't have enough money from your tax base coming in, you cannot improve your network. You can't add more. And let's take and this will be the last thing I say for today, but let's take the Driver's License Bureau, for example. Anybody tried to get a driver's license renewed in Texas in the last year? Not in the last 3 months. Let's forget about COVID-19 for a minute. In the last year, has anybody ever had to go to the Driver's License Bureau to get a new driver's license? Anybody? And what was your experience like, Soraya? Was it an excellent experience and there was plenty of operators to help you? Or did you have to wait? I suspect you had to wait in line for 2 or 3 hours or more, or you were turned away. 1 hour wait, that's actually pretty good. So the state of Texas and the Driver's License Bureau is not very well funded because we don't have first of all, we don't have a state income tax. So we don't have the network appropriate to meet the demand, to meet the needs of all of the drivers in Texas. So it really suffers. But we can only, again, cost, and when we get to that cost analysis, the bottom line is, what's this going to cost? If we can't afford it, we can't afford it. So even some of those mandatory items go away. And that's why things take so long to get updated and upgraded at the state or the federal level, not just because it's huge, but because they have to operate with a limited amount of dollars, which is generated by taxes and by speeding tickets and things like that. Okay, I'm going to stop there because I got to get ready for the 4 o'clock class. I'll make it, what I'll do for the rest of this chapter is I'll make a Zoom presentation and stitch it to this one. I'll upload this one later, okay? So Good luck on your test tonight. For those of you that haven't taken the test, I'll try to be available on my cell phone. You can text me at that 409-331-JAKE number. If you have a technical emergency, like your power went out or your internet went out and you were in the middle of taking the test or something like that, I'm not going to answer any content questions, but I will help you with tech issues while you're taking the test, okay? See you guys tomorrow on Zoom at 2, hopefully. Hopefully there's no more power outages or brownouts or issues. You're welcome.